All right, here's a really quick review on all the operations that we have learned as far as matrices. Matrices, plural for a matrix. Matrix means one. More than one matrix is considered to be a matrice. So first of all, we did talk about a matrix having rows and columns. So all matrices have dimensions, and those are rows by columns. If you have trouble remembering this, just think about RC cola. The rows will come before the columns. So in this particular matrix, there are 2 rows and there are 3 columns. Rows are going to go across and columns are going to go up and down. Rows are going to go across, columns are going to go up and down. So if we were just doing the dimensions of this matrix, we would say it's a 2 by 3. Because it has 2 rows and 3 columns. Adding and subtracting work exactly the same. So I'm not going to show you subtraction, but I will just show you an addition problem. When you're adding or subtracting, your dimensions do have to be the same, and both of these matrices have 2 rows and 3 columns. So anytime you're adding or subtracting, your matrices have to be the same, and you'll just add or subtract depending on what the sign is between your 2 matrices. You'll add or subtract the numbers that are in the same location. So we'll do -2 plus -1, which is -3, 3 plus 5, which is 8, 0 plus 7, which is 7, 4 plus 0, which is 4, 5 plus -2, which is 3, and -1 plus 4, which is 3. So adding and subtracting, fairly simple. Just make sure you have the numbers in the right location and you're either adding them or subtracting depending on what the sign is between your 2 matrices. We have something called a scalar. Anytime there's a number on the outside of your matrix, they're asking you to multiply that number on the inside. And so we're just going to multiply everything by -5. So we're going to get a +10, -35, -45, -55, +5, and -20. If you have more than one operation to do, like if you have a scalar and then you have something in parentheses, you're just going to follow order of operations. So for instance, if you had a matrix A and it said add and then it had parentheses and then it had 5 as your scalar times your matrix B, then you would do that 5 times B first before you added it to A. You would follow those, please excuse my dear Aunt Sally rule. Anytime you're doing multiple operations, we would just follow those rules. Multiplying is a little bit harder. When we're multiplying, we're going to do rows times columns. It's the first row in the first matrix times the first column in the second matrix. If you're going to have to multiply more than one pair of numbers, you'll have to put those numbers in parentheses. So we're going to have to do 1 times 1 is 1, 4 times 0 is 0, 2 times 1 is 2. That's what you get when you multiply the first row times the first column. Then we're going to go to the second column. First row times second column is going to give us 2, -4, +2. And then first row times the third column is going to give us 0, +4, and +4. Everything that I have written comes from multiplying by the first row. Now you're going to go second row. When you're multiplying by the second row, you're going to write all your answers in the second row. So second row times first column gives us 0 plus 0 plus 1. Second row times the second column gives us 0 plus 1 plus 1. Second row times the third column gives us 0 minus 1 plus 2. And then you would simplify all those parentheses, and you would get 3, 0, 8, 1, 2, and 1. When you're multiplying, you may want to look at your dimensions. So the first matrix is a 2 by 3. The second matrix is a 3 by 3. So remember, some matrices it's not possible to multiply them together, but what you're doing is you're checking the inside dimensions. So if the inside dimensions are the same, and they are, both of those are 3s, then the outside these outside dimensions, these will be the dimensions of your final answer. So if we go down here and look at our final answer should have 2 rows and 3 columns, and it does. So that's just a way for you to check when you're multiplying. Finding the determinant, we have the 2 by 2 determinant, which is fairly simple. We're going to start in the upper left and we're going to cross multiply, and we're going to get -2. So the determinant formula says start in the top left, multiply diagonally, and you get a -2. The formula says subtract, and then you multiply the 5 times the 3 and you get 15. -2 minus 15 is going to give you -17. The 3 by 3 determinant's a little bit more difficult. The first thing that you'll do is you'll start by rewriting the first 2 columns on the right hand side of the determinant. And by the way, the determinant symbol looks like absolute value, but in the context of this problem, if you have something that looks like absolute value around a matrix, it's not absolute value, it's the determinant. So you're going to rewrite the first 2 columns on the right hand side. You're going to start multiplying in the upper left, just like on the 2 by 2, and then you'll have 3 pairs of diagonals. You'll multiply those numbers together and you'll get -9 minus 2 plus 0. Those will go in parentheses. The formula says that you always subtract, and then we're going to multiply the numbers that are in the other diagonals. So those are the diagonals going from bottom left to upper right. So that's going to give us +3, +4, and plus a 0. You'll simplify each parenthesis, so we'll get a -11 minus 7, and then we'll simplify from there. -11 minus 7 is -18. So you have your 2 by 2 determinant, and you have your 3 by 3 determinant. Last thing is the inverse. Finding the inverse of a 2 by 2, and these should not be absolute value bars. That's my mistake. They should be brackets. There is a formula for the inverse here. It's 1 over A times D minus B times C. And then we will swap the places of the A and the D. So the D comes here, the A goes to the bottom right. And the B and the C don't change places, they just change signs. And this formula is all based on a general matrix where A and B are in the first row and C and D are in the second row. So this would be your formula. So for the matrix that we have, we'll do 1 over, start in the upper left, 1 times -2 is -2, minus is in the formula, 4 times -5 is -20. Then we'll swap the numbers that are in our A and our D. These are our A and our D spots, so those numbers swap. So the -2 goes to the top left, and the +1 goes to the bottom right. And then the 4 and the -5 are in the B and the C spot. So these numbers, you just change their signs. So +4 becomes a -4, and -5 becomes a +5. Then you'll simplify your number out front. That's going to be your scalar. -2 minus a -20 is going to be -2 plus 20, so it's going to be a +18. So your scalar is going to be 1/18. When you're finding the inverse, they're going to allow you to leave your scalar on the outside because it's usually going to be a pretty ugly number. They'll allow you to leave that scalar on the outside, and then you'll just write your answer like I've written it. Some matrices do not have inverses. For example, if I gave you the matrix, we made one of these up in class, so like if you did a 2 here and let's say a 9 here, and then you did a 3 and a 6. And then when you go to find the determinant, you're going to do 1 over A times D, so it'd be 2 times 9, which is 18, minus B times C, which would be 3 times 6, which is 18. And you're going to end up with 18 minus 18, so that's going to give you a 0 in the bottom. And we know we can't divide by 0. So this is an example of a matrix that does not have an inverse. Please make sure that you do your review, and hopefully this short video will help you.